Hello, welcome to my channel. Chapter 1, Exercise 1B, First Roman, which is important for 2 marks. So we will solve each and every problem in a systematic way. So the first question of First Roman first bit is z is equals to 2 minus 3i into 3 plus 4i. So we'll multiply each and every term. Therefore z is equals to 6 plus 8i minus 9i minus 12i square, which is equals to 6 minus I plus 12, since I square is equals to minus 1, which is equals to 18 minus I. Therefore, we need to write this in the a plus ib form, which is equals to 18 plus of minus I. A is 18 and B is minus 1 here. This is the answer. Second sum, given z is equals to 1 plus 2i whole cube. We know that a plus b whole cube is equals to a cube plus b cube plus 3a square b plus 3ab square. So here a is nothing but 1 and b is nothing but 2i. So we'll expand this. What we get is z is equals to a cube is 1 cube plus b cube is nothing but 2i whole cube plus 3a square 1 square b 2i plus 3a into b square, so that is 2i whole square, which is equals to 1 cube plus 8i cube plus 3 into 1 square is 1, so 3 into 1 is 3 only, 3 into 2 is 6, so this is 6i plus this is 3 into 4i square. This is equals to nothing but 1 plus 8i cube plus 6i plus 12i square. Since I square is equals to minus 1 and I cube is nothing but I square into I square is nothing but minus 1. So minus 1 into I is minus I. So the value of I cube is nothing but minus I. Now we will substitute these values in this. So we get 1 plus 8 into minus I plus 6I plus 12 into minus 1, which is equals to 1 minus 8I plus 6I minus 12 equals to minus 11 minus 2i. Therefore, z is equals to minus 11 plus of minus 2i. This is the answer. Third question, given z is equals to a minus ib divided by a plus ib. So as denominator has a complex number, we will rationalize this with the a minus ib. So we get z is equals to, when rationalized, a minus ib into a minus ib, because the rationalizing factor of a plus ib is nothing but a minus ib. So here we will get a plus ib into a minus ib. This is nothing but a minus ib whole square by a plus b into a minus b, which is nothing but a square minus b square. Now this is equals to a minus b whole square is nothing but a square plus b square, that is ib whole square, which is nothing but I square b square minus 2ab. Here b is ib, no? So we get 2abi by a square minus I square b square, which is equals to a square plus I square b square minus 2abi by a square plus b square. Since I square is equals to minus 1, substituting we get a square minus b square minus 2abi divided by a square plus b square. Now from this we will separate the real part and the imaginary part. Therefore z is equals to a square minus b square. This is the real part in the numerator, divided by a square plus b square, minus, this is the imaginary part, so minus 2abi by a square plus b square. You can write it as a square minus b square by a square plus b square plus of minus this value if you want, that is a plus ib form, or you can leave the answer like this. So this is the answer. As it is given, we have to write these complex number in the form of a plus ib. We need to write in this form only. We have to get a plus ib only. This is a is nothing but this, and here ib is nothing but this, and in the middle plus sign is there, so this is in the form of a plus ib. We have to write like this only. It's better if you write this only, because it is given that we need to find the complex number in the form of a plus ib. That's why we are writing in this way only. Now fourth question, given z is equals to 4 plus 3i divided by 2 plus 3i into 4 minus 3i. First what we will do is, we will simplify this denominator. So z is equals to 4 plus 3i as it is in the numerator. In denominator we get 4 to the 8 minus 6i plus 12i minus 9i square, which is equals to 4 plus 3i by 8. This is nothing but plus 6i. Since I square is equals to minus 1, we get here as plus 9, because minus 9 into minus 1, right? Minus 9 I square is nothing but minus 9 into minus 1, which is equals to 9. This is equals to 4 plus 3i, 8 plus 9 is nothing but 17 plus 6i. Now we will rationalize this with the denominator. After rationalizing, we get it as z is equals to 4 plus 3i. Rationalizing factor here is nothing but 17 minus 6i by 17 plus 6i into 17 minus 6i. This we need to multiply each and every term. So 4 into 17 is nothing but 4 7s are 28, 4 5 6, 68 minus 4 into minus 6i is minus 24i. 17 into 3i is nothing but plus 51i. 3i minus 6i is minus 18i square by, this is a plus b into a minus b, which is nothing but a square minus b square, that is 6i whole square, which is 6 square into I square. Now this is equals to 68 minus 24i plus 51i plus 18 by 17 square plus 6 square, since I square is equals to minus 1. Okay, now this is equals to 68 plus 18 is nothing but 86, and here minus 24 plus 51i is there. So we'll subtract this, we'll get a positive sign here, and if we subtract we get it as 27i by 17 square is nothing but 289. Substituting it, we get as 289 plus 6 square is nothing but 36. Now this is equals to 86 plus 27i by 325. Therefore z is equal to 86 by 325 This is the final answer. Fifth question, given z is equals to minus root 3 plus root of minus 2 into 2 root 3 minus I. Now first from this we will consider root of minus 2, which is nothing but root 2 into root of minus 1 only, right? Now we know that I square is equals to minus 1. Therefore, what is the value of I? It is nothing but root of minus 1. Therefore, root of minus 2 is nothing but root 2 into I, that is root 2I. So if you first substitute this here to solve it in a simple way. So it is minus root 3 plus root 2I into 2 root 3 minus I. Multiplying each and every term, we get minus 2 root 3 into root 3 is 3. So minus 2 into 3 plus root 3I plus 2 root 2 root 3I minus root 2I square. Now this is equals to minus 6 plus root 3I plus 2 root 2 root 3I as it is, right? This will become, since I square is equals to minus 1, we'll get it as plus root 2. Now from this the real parts are minus 6 and plus root 2. We'll write it first, minus 6 plus root 2. Then the imaginary parts will write, that is plus root 3I plus 2 root 2 root 3I. Now from this we can take root 3 common, no? So we'll take root 3 common. Root 3I common we can take actually. So root 3I common into 1 will get plus 2 root 2. That is nothing but minus 6 plus root 2 plus root 3 1 into 1 plus 2 root 2I. This is the value of that. This is the final answer. Sixth question, z is equals to minus 5I into I by 8. So we will simply multiply this with this. So we'll get minus 5I square by 8, which is equals to 5 by 8, as I square is equals to minus 1. Because minus 5 I square is minus 1, no? So minus 5 into minus 1 is plus 5. So 5 by 8. Therefore z is equals to 5 by 8. This is the real part. We don't have any imaginary part, so we'll consider it to be 0. Plus 0I is the answer. We are writing it as 0I because we need to write the answer in the A plus IB form. That's the reason we are writing here 5 by 8 plus 0I, where A is nothing but 5 by 8, B is nothing but 0. Okay. Seventh problem, given z is equals to minus I into 2y. So here also I'll just multiply it simply. We'll get it as minus 2I square. Since I square is equals to minus 1, z is equals to 2. This also will write it as z is equals to 2 plus 0I in the form of A plus IB. So this is the answer. Given z is equals to I to the power 9. So we will write it as I to the power 8 into I, which is nothing but I to the power 9 only, no? Now I to the power 8 can be written as I square whole to the power 4, this into I. So I square is nothing but minus 1. Substituting what we get, minus 1 to the power 4 into I. We know that when any negative number is raised to a power which raised to an even power, we get it as positive only. So minus 1 to the power 4 is nothing but plus 1 into I, which is equals to I. Therefore z is equals to I. We will write it as z is equals to 0 plus I, A plus IB form, where A is equals to 0 and B is equals to 1. This is the answer. Ninth question given, z is equals to I to the power minus 19. So first we will write it as z is equals to 1 by I to the power 19 to make this power positive. Now this can be written as 1 by I to the power 18 into I, right? Which is nothing but 1 by I to the power 18 can be written as I square whole to the power 9 into I. Therefore, z will be equals to 1 by I square. Since I square is equals to minus 1, we get it as minus 1 to the power 9 into I. Therefore, z is equals to 1 by minus 1 to the power 9 is minus 1 into I, which is equals to 1 by minus I. This is z. Now this is nothing but a complex number in a denominator. Therefore, we will rationalize here. We get z is equals to 1 rationalize into I minus I into I, which is equals to I by minus I square. We can cancel, therefore this will be equals to, we will not cancel this, we will write it as z is equals to I by minus I square. No, we know that the value of I square is nothing but minus 1. We will substitute here. We will get it as I by minus of minus 1, which will be equals to I. Therefore, z is equals to I, which is nothing but z is equals to 0 plus I. This is the answer. Now 10th question given, z is equals to 3 into 7 plus 7i plus I, which is multiplied by 7 plus 7i. Now first we'll multiply this term 3 with this whole part and this I with this whole part. So what we'll get is z is equals to 21 plus 21i plus 7i plus 7i square. Since I square is equals to minus 1, we will get the value of plus 7i square as minus 7 here. So it is nothing but 21. We can add these both terms, which is equals to plus 28i minus 7. Now 21 minus 7 is nothing but 14 plus 28i. Therefore, z is equals to 14 plus 28i is the answer.